Hey everybody, welcome to another Probably Private. And today we're going to dive into a paper and also an open source repository called RouteLLM and start thinking about how might we use the concepts from RouteLLM in a local first environment. Okay. So if you're new to prompt routing, let's get started talking about what would even be our motivation. Why should we route queries? Why is this useful? Well, the main thing we're going to talk about today is cost benefit. So if you're normally using something like Claude or OpenAI and you're paying for use, now maybe you just have a base fee per month, but eventually that limits, I think, at some level of tokens. So the idea would be, okay, how do you save either your free or your already paid for tokens for only the best queries and otherwise maybe use a local model, something that costs you only the amount of energy to run your computer. So that's one thing. Another reason might be privacy benefits. So you probably found my work because of my work on privacy. And what you might start thinking about doing is queries that are private. Maybe you use local first models or local only models, or maybe you do, like we've been showing, some redaction before you send it on. And maybe one way of you routing this is deciding, okay, first it gets routed to a redaction and then it gets routed to another model. So that could be another reason to route queries to different models. And you might also want to test out new models quickly. So a new model comes out, maybe you are like, okay, how can I use this? I don't want it to mess up my workflow, but I'm happy to integrate it into all of the models that I use. And one way you could do is by incorporating it into kind of some of the concepts that we'll see today and decide where does it fit based off of evaluation data that you've already collected. And if you're not collecting evaluation data yet, take a look at my video on how to get started with evaluations and just start building the types of evaluation data you might need in order to test new models quickly. And finally, you yourself might notice, just like you've maybe noticed in my videos, I have a bias towards certain models. I use them more often than other models. You probably have your own biases. Maybe some of that is informed by your experience, and that's fine. I'm not trying to judge you here or have you judge yourself. But maybe sometimes there's really good marketing that we find attractive, and then we think, oh, that model must be better. I'm going to use it for things. And one cool thing that routing can show us is where maybe some of that marketing and human bias lives, and we can start actually thinking through more mathematically what models are good at what tasks and how do we want to then separate those. Okay, so now we're ready to get started. Let's move on. RouteLLM, what is it? What does it do? Here's a really cool graphic from the website, which I'll of course link, and they have a GitHub that I'll link. And they were basically trying to gauge on the cost versus model performance, where do they end up between, they always chose 2 models, but you could expand their thinking to choose 3 models, 5 models. Adds a little computational overhead. We'll go over that. But this idea of routing between a cheap model, here they used Llama 3, 8 billion, and an expensive model. They used GPT-4o for their work. And can we find a way of the amount of queries we send to the expensive model versus what we send to the cheap model based on some measurements and some experiments that they ran? So they developed a really cool, I thought, novel idea for a comparison score. They call it the call performance threshold. It's basically dependent on a bunch of other metrics that they outline in the paper, and we're not going to go through every single one and every single equation. I'm going to link the paper. You can read it yourself, or if you have a question, please put it in the comments, and I'll make sure that I respond. But this call performance threshold basically says, we think that the more expensive model is going to have such a high increase in the performance of the response that we're going to send it to that expensive model. And essentially what you want is a low call performance threshold, because you want only a few of the most complicated queries, so to speak, or prompts to be sent to the expensive model. And then the rest, you want to spend your time on the cheap model if possible. So if you can keep this number low, it means that you're only relying on the expensive model for those really where the ratio is so big that you really want that extra performance. Okay, so I'm going to try to break down a little bit of how they did that. First off, they measured the quality of the response using the prompt and evaluation data. So they already use data sets that you can get on Hugging Face and Kaggle that are openly available, benchmark data, and they measured the quality of response using some standard metrics that are used with the evaluation data set. So how close is the response, for example, to the response that we want, right? And so they already had this evaluation data. This is, again, why I say start having your own evaluation data, start having examples of data that you want to use in your normal workflows and save them places so that you can get an idea, what do I like, what do I not like? And you can also develop these metrics like the quality of the response. And when doing this, then they had the expensive model quality versus the cheap model quality, or we can think API-based versus local. We can think privacy first versus not privacy, right? So we could do this paradigm on a variety of different types of measurements that we want to use. And then they basically choose a quality gap that you're comfortable with. So you're going to set the performance ratio at some percentage, right? At what shift in performance do you want to go to the expensive model versus the cheap model based off of these quality metrics? You're going to do that. And then eventually you're going to use that information. So they did it all with just evaluation data that was available openly and publicly to build a router that knows your preferences. And what they found two methods work really well. One comes out of kind of NLP, LLM workflow that basically, I would say is a probability informed router there. But another thing that they found worked really, really well is simple matrix factorization. This is a trick, it's a practice in recommender systems that is also pretty cheap. That basically is just like, we notice that these queries are similar to these queries, and that in that case, you prefer this model, here you go, right? Which is really cool. So if you want to check this out, check out the paper, check out the code. It's all there. If you have questions or you're like, Catherine, can you explain that better or in another way? Please let me know in the comments. I'll do my best. But I was thinking through what are additional features you could implement. So essentially, especially if we're thinking matrix factorization, we could append other features that we think might be important for our recommender. So what else could we add that they didn't add in the paper because that wasn't their goal, but that we could add if we wanted to? We could add in a calculation for token cost. So here they just basically said, expensive versus cheap, but we could actually start recording and calculating in token cost as a part of that performance score, or as a part of essentially the cost optimizer part of their tooling, right? So we could add that. I think actually they might have even added that by now to the open source repo, but to make sure to take a look and see, but that's something we could add. We could also add latency. So we'll get a little bit more into how do you actually measure and record latency, but we could even just always prefer here local versus external, right? So over the public internet versus local. We could measure user happiness. So again, you can add for yourself in your own workflow a way to give thumbs up, thumbs down. And to be honest, this is like something you've seen already in all the interfaces. I would be extremely surprised if they weren't using this information to optimize query routing at large scale AI providers and vendors, right? of not only for their own training and so forth, but even without their own training to start to say, these types of queries we route to these models, these types of queries we route to these models, and so on and so forth, okay? So use it for yourself. Use it for your own task. Take whatever insights you can gain, right? Again, already said local versus cloud. So deciding that based on your own preferences that you might want to tune, right? Or you might want to have something there that says, we think that this prompt has private information. We route it local only, something like this. Task-related features. So some of the routers that I've come across are very task-related. So they're like, oh, this is a computer vision output, so we put it to the vision model. Or a lot of the agent-based workflows kind of use these types of switching. I would advise that you only do that after you look at whether more machine learning informed choices work, but it is an additional feature you could add. So if, let's say, you know that a task is certainly a vision, then, and you can add that like as a one-hot encoding, or add that as an additional feature via text or something else, then investigate adding that. Model freshness. So you could prefer either tried and true models, so models you've been using for a long time, and weight towards those, or you could weight towards fresh models. So you could say, this model I'm integrating into the stack, I want you to actually over choose it for a while until it has the proper evaluations. Although with many of these evaluations, if you're actually saving them, you could rate them regularly. So again, just to repeat, use your eval scores, be able to incorporate a fresh model, run it on your evals, get an idea pass fail based off of the data you already have, label some more data if you need to, if there's a lot of uncertainty, is it pass or fail, and then move along and make sure that you're being able to route your queries in cheap, privacy-friendly, and effective ways for whatever your workflow is. So you can add things here. So if you have other ideas, or you're like, Catherine, I already did this, I added these things, they work great for me, please feel free, share with me, tell me in the comments, post your code, post your repos. I'm very happy to see what's out there. And so again, repeat, show me what you're building. Have you done some routing? Have you dabbled in routing yet? If not, what are you excited to try with routing? And if you liked this video, if you found it insightful, don't forget to share it with your friends and subscribe, because it keeps me producing hopefully useful content for you all. So I'll see you next week.